So excited to talk to you about Desci today and kind of give a broad level overview for what decentralized science is, why we need Desci, and how it works. I recognize, of course, many familiar faces also in the audience, so I'm curious by a show of hands, like who of you is already quite familiar with decentralized science and knows of organizations like VitaDAO? Okay, so almost everyone. So I'll try to jump into some depth. So I'll start with kind of like why Desci and why we need Desci, what it also sets out to solve, and then what it looks like in practice, how it works in practice, and kind of some hopes for the future. So I always like to start off with this graph of kind of science as the engine of human progress, and I think it's worth emphasizing that I think our modern world and like well-being is largely due to scientific progress, and of course also more broadly technological engineering progress, from the agricultural revolution to kind of like the industrial revolution, and of course really just like different breakthroughs in the scientific method. And really broadly applying it and translating science into actual inventions that benefit all of us. But I think it's also very broken, and I think there's a whole field called meta science, which actually is like the science of science, which is quite interesting, trying to use the scientific process to understand what's broken about science. And there's a lot of lessons there, but it's theoretical, so they don't apply the lessons. It's more like scientists trying to ramble about how science is broken, not really able to change anything about it because they are not the funding bodies, they are not the coordination mechanisms, they're just a set of academics trying to reflect on how academia is broken. And I think I view decentralized science almost as an applied meta-science, what means we can use the insights that this field has about how scientific funding, replication, competition, communication, and a bunch of other central pillars of science are broken, and how we could devise solutions. And I think, importantly, like Desci is quite new, so I think we're just getting started to experiment with some potential solutions. I think ideally, the really big solutions, I think, are still ahead of us. And I would invite all of you to participate in finding the solutions and helping to come up with these experiments, and then learning and do iterated cycles of improvement to ultimately make science better. So to just jump into some of the problems on funding, they are also widely known. Like funding is very insanely centralized. So there's big funding bodies in the US, like the NIH, and they are one of the major funders of science. There are a few small philanthropic arms, and of course venture capital, for example, for later stages. But at the end, like especially for early stage science, it's usually top-down, bureaucratic government entities funding early science. I think it's actually more functional, for example, for startups, where it's like a free market, VC world. So funding is highly competitive and very also like distributed, for example, towards repeatedly the same people and old people. So there's like an interesting statistic that less than 2% of the funding goes to under 45-year-olds, which really means that like a lot of the funding goes to usually like quite old professors and people with tenure. And then, of course, also widely known, science has a huge replication problem. For example, there was like an Alzheimer's study recently that got debunked, and it turned out that people faked science on which tens of billions of Alzheimer research have been built on. Basically, you can throw all this taxpayers' money into the bin because none of this research will work because someone in the chain created fake science that didn't replicate, which means it couldn't be reproduced, it didn't work at the end, which was the kind of like Alzheimer hypothesis. And then on competition, it's very hyper-competitive, and not even in a good way. I, for example, think like maybe the free enterprise VC world is also hyper-competitive, but maybe in a more functional way. I think in science, it's a very zero-sum, like underpaid kind of competition with perverse incentives, like publish or perish, like just getting as many citations as possible, like almost like playing a game that you can't win because you're optimizing for the wrong thing. And connected to that, I think all these publications then are paywalled and no one even can read them. So like really on the communication side, science is very inaccessible, which is very weird if you consider that all of you fund science through your taxes. But you can't even read the science you funded. So I think that's also something crypto can solve. And then also science could just be forgotten in a sense where I think things, for example, like decentralized storage promise permanently stored science. Like ideally every scientific artifact, every scientific data point should be backed up on as many computers as possible so we don't lose it. A lot of some of the most important research in the world just gets lost. Like maybe you still have the paper, but you have no clue how they actually did the research. You couldn't replicate it. So I think permanent storage of scientific data and research is also quite important. So as I mentioned, a lot of the problems stem from centralizing authorities. I think decentralization offers solutions. I think there's also a lot of problems beyond just like the centralization, decentralization axis. But I think actually there are interesting ones that come from that. And then I think to break it down maybe in the why, what, and how, kind of like the why of these I would say is to build an open science movement, apply the lessons from meta science, make science more collaborative and democratic. Like ultimately, less than 0.01% of the world is involved in science if you think about it directly. Like there's very few scientists compared to humans in the world. And very many people are not able to get involved in science. Like there's a huge barrier to entry in terms of like you need a PhD. It's even almost like gate capped, like a club that you can only get in if you have a PhD or if you have a lot of money and are a billionaire philanthropist or something. Like most regular people are not involved in science. They can't access it, they can't read it, they can't fund it, they can't participate in it. And I think that is something which decentralized science can solve. So the what I view as almost like a global open alternative to the current scientific system that anyone in the world can participate in. And then how? Really by enabling scientists to raise funding from everyone in the world, run experiments, share data, distribute insights, and for everyone in the world to participate actively in the scientific process through scientific communities that I'll touch later on. So what if science is decentralized? And I think what's interesting is in the ethos of decentralization, it shares a lot of things, I think, with potential solutions for science. Mainly ethos of decentralization, open source, transparency, really an ethos of enabling global access and collaboration, no matter your language or your education. Censorship resistance that fosters an open culture, which I think is also very key to science. Like literally in many countries, I won't name them, but you can't publish research that is critical to the regime or to the country. Like COVID is a great example. Like if you look at some big places that go unnamed, you couldn't publish COVID research that would challenge specific assumptions. And as mentioned before, like permanent storage of scientific data, I think is also quite critical. So I just, on a side-by-side comparison, you can also find it on ethereum.org/Desci. I'm kind of trying to compare TradSci to Desci. And of course, there's the axis of funding, collaboration, labs and infrastructure, publishing, peer review, and IP. And in the decentralized system, all of that is better and solved, of course. And I'll go into some depth of some examples on how this looks like in practice. So there's some verticals that I want to focus on. The first one is funding, where Stefan already touched on IP NFTs and tokens, which is the very first, almost prototype experiment. I think there's still a lot to refine, improve there to make it the perfect funding mechanism, but I think it already shows the way. There's, of course, a lot of public goods funding mechanisms, some of which we're also involved in. Then on the coordination layers, we have biotech DAOs, kind of like scientific collectives like VitaDAO, that really bring together a large group of people to coordinate, which I think really helps because a lot of people have the desire maybe to fund longevity research or climate research, but they don't have the time to figure out what to fund. Or maybe they just have the desire to go to a community to learn about science, to discuss science, And that's really, I think, the point of these native online communities of scientific DAOs. Then there's a whole vertical of publishing and reproducibility and identity and reputation, and also a bunch of other verticals, a few examples which I will pick. With Molecule, we are focused on making IP transactable specifically, and enabling sustainable funding loops for research organizations where they can fund research and license the research, make money with the research to fund more research. There's a lot of challenges in IP. Because I don't have too much time, I'll skip a bit ahead, but into some of the solutions. The goal is really to make intellectual property digital native and kind of fix some of the problems by really making it more discoverable, making it more liquid, and enabling people to fund research directly, and doing so by bringing it on-chain, which also enables then scientific DAOs like VitaDAO to fund research natively through a digital way. This is what the Molecule Marketplace looks like. I'll skip a bit ahead because Stefan touched on some of the architecture. So one of the newer things we did, which this visualizes well, is really, which is at the heart on the more crypto side of things, is the IP NFT, which is basically a one-of-one. It's like a one research project, and what you can do is tokenize it and split it into infinitely many parts, and that basically turns an IP NFT into many IP tokens. It's fundamentally still the same thing, but we, as the whole audience, could collectively, through IP tokens, own one IP NFT. Of course, you can also govern it through a BioDAO, for example. So the purpose is really to get individual stakeholders into research projects. You could imagine that the researcher has some IP tokens, the community has some IP tokens, and the individuals that are really excited about a specific research project could also fund or earn tokens for their work. And yeah, maybe to just go, yeah. And we've basically done this with VitaFast, which is the first IP token. And then I want to touch on why BioDAOs in this picture are also quite important. I think at the heart, it's really enabling kind of an internet native community of patients and enthusiasts. Like in the example of VitaDAO, of course, everyone is a patient of age-related diseases like Alzheimer and cancer at some point. Hopefully not, but I think thus far, everything points to everyone being a patient of age-related diseases. And then really the goal is, of course, not everyone in the world cares, for example, about age-related diseases. So the goal is really to bring together also enthusiasts and researchers in an online native community, no matter the border or country. And it's very cool to see that, it's actually not just the speak, but actually you, in VitaDAO, I've met people literally doing longevity research in Turkey, Kazakhstan, across the US, America, Asia. And I think that's quite hard in a traditional system where it's oftentimes quite local. It's people in Boston at Harvard doing research with other people at Harvard. It's not very global. And it's also very physical. It's not digital native, and thus also creates high barrier to entry because most people in the world don't sit in Harvard, they sit somewhere in the world. So it's really, truly internet first research organizations that are truly open and networked. There's a really great book on this by Michael Nielsen called Networked Science, kind of painting the picture why this is superior. I think with examples like Wikipedia even, we see great examples of open online native digital organizations being quite superior to physical closed organizations. So VitaDAO, I've touched on it. I'll jump into some of the projects and examples what VitaDAO has been doing on the publishing, on the funding side, publishing side, and even longevity network state side, and a bunch of other experiments. So this is an overview of how the current research flow works for VitaDAO. So basically, researcher applies if they qualify, there's specific, basically, considerations. Then there's a due diligence by an evaluation team of experienced people in the DAO that basically take a look and due diligence the research. The team presents to the community with the community basically then has also the evaluations from the experts. So it's also a nice way for scientific communication because the whole community, like a lot of them might not be PhDs, but they can learn about why the research could be interesting and hear also from an independent evaluator what the pros and cons are in some of the evaluations. And then with this expert review taken in, the experts make a recommendation to the community. But at the end, the community decides. And the community, of course, is composed of researchers, but also just of enthusiasts and people curious to understand which research is most promising. And then at the end, if at least 51% vote yes, the research is funded and advanced. So VitaDAO funded over 5 million of research to date. I think roughly 19 projects, if I'm not mistaken. And some of them are making amazing progress, and you can see all of them on vitadao.com. What I think is interesting to highlight and less often talked about is now also experiments on all the other verticals that I mentioned. So for example, VitaDAO created Longevist, which is a journal, but quite nicely it also summarizes the papers. They're reviewed and selected by some of the leading researchers in the world, to be honest, which was pretty amazing to see. And all of them are open and accessible. And actually, they're also on-chain stored through collaboration with Desci labs and peer-reviewed through Longevity Review, which is kind of like a Reddit online forum for peer review, where actually peer review happens openly. Peer reviewers are compensated, both of which is not the case in the traditional peer review system. It's not happening openly, so sometimes scientists competing with each other are reviewing each other, and in a very intransparent way, and not even compensated. So I think that's an exciting experiment on publishing by VitaDAO. And they already have the second edition. And to be honest, it's one of the first ways for me now to keep in touch with some of the leading research coming up, because they really select also for some of the most promising research and vote on it on-chain through Snapshot. Then VitaDAO, we experiment with network states, which of course through Balaji and others got popular, and actually really closely teamed up with Vitalik and many others to a 2-month-long pop-up city in Montenegro. They kind of want to give us a long-term place now, and the idea is really to bring together longevity enthusiasts and communities in physical locations. And we literally discussed with the Montenegrin government to declare aging a disease, bring in kind of research labs and support from the government to create a longevity hub there. So it's really exciting to see. There's actually coming up early next year in Prospera, which is in Honduras, one of the first kind of charter city network states. There's a 2-month-long longevity experiment and city, and a lot of actually the leading network states, some of which have already have physical places secured, are keen to collaborate with VitaDAO on the healthcare system. So basically, they want to consult VitaDAO, build a longevity-first little pop-up city, and really also tap into all the community members to visit their city, access cutting-edge research. And in the Prospera example, it's interesting. They actually have a medical-free zone. So they actually have, for example, longevity clinics that can do gene therapies that you can't do in the US or Europe, which is of course also more risky. So don't try at home. And then there's a few other experiments which I think are interesting to highlight, which kind of naturally came out of VitaDAO, and I was also quite involved in. One was a quadratic donation round, which you can see on the right with VitaDAO, where, for example, Vitalik put in $500,000, and a bunch of other community members. Actually, shout out also to Stefan from Gnosis, who also put in money with Vitalik. And that funded a lot of different experiments, from literally open research to open scientific platforms in longevity to, for example, also the student fellowship that we started, which funded 55 students, to a longevity prize, which awarded the first prizes to different people solving different problems in longevity, and also funded things like a VitaDAO hackathon, which is an online hackathon for people to hack a weekend on solving important problems in longevity. Okay, I touched on this. I want to end on a bit of a future outlook. So we're just getting started. Kind of I would say Desci really only existed since 2021. So it's barely 2 years old. Of course, there was some similar movements before, like blockchain for science, I think in 2018 a bit. But that really died down. I think Molecule is the only survivor of that era, like because it already started in 2018 a bit. So I want to touch on some of the future of DeSci. I think one interesting one is really that I think the future is quickly moving to digital native, AI-driven, closed-loop R&D. And I'll unpack it. What I mean by it, it's basically, of course, ChatGPT and other things. And they increasingly will be able to come up with scientific experiments, potentially even execute them through cloud labs, evaluate the results, or for example, in VitaDAO's case, to find deal flow, to evaluate deal flow, to make progress on research. And I think actually like an autonomous, decentralized system is perfect as a playground in that, while not completely disenfranchising humans. So you can still see maybe the AI making a proposal to the DAO. Maybe even some AIs already vote on the proposals or execute the research. And I think that will be very interesting. And with organizations like LabDAO, we're starting to do some also AI-driven drug discovery with VitaDAO natively, actually through on-chain native mechanisms. Then really in broadly kind of DeSci upgrading the scientific method and stack that I touched on before, like really continuously looking at problems, devising solutions, figuring out if it actually solved the problem, and coming up with better experiments. So I think, of course, not just our effort, but every effort in DeSci, I think, is trying to improve a specific problem. I think increasingly it will create like a truly global, autonomous, and decentralized R&D world where everyone in the world can contribute, which touches on this, enabling every human to be a scientist and participate in science, enabling patient and researcher communities to govern cures and access to medications, like governing diabetic medicine, and thus also the pricing and other aspects. Then making kind of like science as easy as using a website. Like ideally one can log in and learn about science, give feedback about specific research, and I think that's really the future we're trying to build. Then making sure that also scientists are fairly paid and incentivized for the work, also in asymmetric ways. Like if someone in a DAO like helps to come up with a cure for like a big disease in their free time, like they should get rewarded for it. In the current scientific system, like a lot of even leading scientists and senior scientists get sometimes less than like an intern in a blockchain startup. So I think that is also something that needs to be solved. Like raising, of course, the scientist salary, not decreasing the interns. And then really making sure that science decouples from institutions, so creating like an alternative to existing scientific institutions that are often gate-kept and very hard to access. And then as a last call to action, feel free to check out some of the pages or like projects that I mentioned and just join a community. It's as easy as just going into the Discord, checking out the website and seeing if there's something that you're excited about. Feel free also, of course, if you're a scientist, apply to get funded. There's also things like the fellowships and other things where you can also just get a funding for a little hackathon or some small project. And then make sure to fund a DAO of your interest or research project, or get rewarded for referring research projects. So thank you very much, and join the DeSci revolution. And you can scan this QR code, which basically has a link tree of every resource I mentioned.
Okay, thank you, Vincent. That was very insightful.